welcome to today's lesson on measures of position. In this lesson, we will tackle another measure of position, which is the deciles. Our previous topic was quartile, which is also a measure of position. So, as a recall, to how many parts do quartile values divide the distribution? Very good. 4 parts. Okay, so for today's lesson, here are our objectives. Number 1, calculate specified measure of position for ungrouped data, specifically deciles. Then perform the given task with accuracy. So without further ado, let's start learning. Let's begin first with the definition of deciles. Deciles are the 9 score points which divide a distribution into 10 equal parts. They are deciles 1, 2, 3, up until decile 9. So since deciles divide the distribution into 10 equal parts, each division in here represents 10% of our data set. Okay, let's say, for example, a score in a data set falls on decile 1. It can be interpreted as 10% of the scores in the data set are less than or equal to the decile 1 value, and the remaining 90% are greater than or equal to the decile 1 value. Moving on, if a score falls on decile 2, it can be interpreted as 20% of the scores in the dataset are less than or equal to our decile 2 value, and the remaining 80% are greater than or equal to our decile 2 value. If a score falls on decile 3, it can be interpreted as 30% of the scores in the dataset are less than or equal to our decile 3 value, and the remaining 70% are greater than or equal to our decile 3 value. Score falls on decile 4. It means that 40% of the scores in the dataset are less than or equal to our decile 4 value, and the remaining 60% are greater than or equal to our decile 4 value. Furthermore, if a score falls on decile 5, it means that 50% of the scores in the dataset are less than or equal to our decile 5 value, and the remaining 50% of the scores in the dataset are greater than or equal to our decile 5 value. If a score now falls on decile 6, it means that 60% of the scores in the dataset are less than or equal to our decile 6 value, and the remaining 40% are greater than or equal to our decile 6 value. If a score falls on decile 7, it can be interpreted as 70% of the scores in the dataset are less than or equal to our decile 7 value, and the remaining 30% are greater than or equal to our decile 7 value. If a score falls on decile 8, it means that 80% of the scores in the dataset are less than or equal to our decile 8 value, and the remaining 20% are greater than or equal to our decile 8 value. And finally, if a score falls on decile 9, it can be interpreted as 90% of the scores in the dataset are less than or equal to our decile 9 value, and the remaining 10% are of the scores in our dataset are greater than or equal to our decimal 9 value. So everyone, that is how we interpret our decimal values. Okay. So how do we find for our unknown decile value? So just like in quartiles, we follow steps. First step is, again, we have to arrange our scores in ascending order or from least to greatest. Next is we locate the position of scores in our distribution. In here, we are using a formula. So this is our formula for the decile. D sub k, which represents our decile, is equal to k times the quantity n plus 1 over 10. Now, if our answer in step 2 is a whole number, no need to proceed to step 3. But then, if our answer in step 2, after we use this formula, k is a decimal number, we have to proceed to step 3, which is the interpolation. Okay, so this is our formula again for deciles. So d sub k is equal to k times the quantity n plus 1 over 10. D sub k in here represents our decile. K represents the decile location. And n represents the number of elements in our data set. Take note that this formula is used to determine the location of our unknown decile. All right, let's have an example. Find the third decile and the fifth decile scores in the following test scores of a random sample of 10 students: 35, 42, 40, 28, 15, 23, 33, 20, 18, and 28. Okay, so again, let's recall the steps. First step, arrange the values in ascending order. Second step, use the formula for deciles to determine the location of the unknown decile. If our answer in step 2 is a whole number, no need to proceed to step 3. But if our answer in step 2 is a decimal number, we have to proceed to step 3, which is interpolation. Okay, so let's first find the third decile value. So to find for decile 3, first step again is to arrange our scores. Okay, so this is now our scores arranged in ascending order. 15 is our lowest score and 42 is our highest score. For our second step, we have to locate the position of decile 3 value in our distribution. And here, we will be using a formula. This is our formula again for the decile. We are looking for decile 3. So our given k will be equal to 3. Okay. Decile 3 is of the form d sub k. So d and d, so k then is equal to 3. Okay. So for example, we are looking for decile 1, k will be equal to 1. If we are looking for decile 2, k will be equal to 2. If we are looking for decile 3, so k will be equal to 3. If we are looking for decile 5, k is equal to 5. And so on and so forth. Okay? Our n is equal to 10 because there are 10 values in our data set. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay. This time, we substitute our given to our formula. So we have here, the position of decile 3 is equal to, we replace k by 3, having here in the given, we replace n by 10, okay? And then we copy the rest in the formula, plus 1 over 10, plus 1 and over 10. We perform the operation. 10 plus 1 is 11 times 3, that gives us 33. And then copy over 10. 33 divided by 10, that gives us 3.3, which means that the decile 3 value is located in the 3.3 or 3.3 position. Okay? And since our answer after using the formula is a decimal number, we have to proceed to step 3, which is interpolation. To perform the interpolation process, okay, we have to first locate the 3-pointer position in our arranged values in step 1. So this is our arranged values. So 3-pointer position is in between the third score and, the third position and the fourth position. Now, the score corresponding to the third position is 20, and the score corresponding to our fourth position is 23. Now, to find for the corresponding score in the 3-pointer position, we have to add the third score and the 0.3 score. So 3 plus 0.3, that gives us a 3.3 or 3.3 score, which corresponds to the 3.3 position. Thus, our decile fee value is equal to 20 plus 0.3 times the quantity 23 minus 20. 20 here is our third score, and 0.3 times the quantity 23 minus 20 corresponds to our 0.3, the 0.3 score. Where did we get 0.3? 0.3 came from our step 2 answer. Okay, the decimal part of our answer in step 2, okay, that is where we got 0.3. And then 23 in here is the fourth score, and 20 here is our third score. So if we multiply the difference of 23 and 20 to 0.3, that will give us the 0.3 score. Performing the process, we have 23 minus 20 is 3 times 0.3, that gives us 0.9. And then we just copy 20 plus. So 20 plus 0.9, that gives us 20.9. Now our decile fee value is equal to 20.9. Okay, next we find for the decile 5 value, or the fifth decile. Step 1, we have to arrange again the scores, and this is now our arranged scores. Step 2, we locate the position of decile 5 value in our distribution. We again use the formula for deciles. We are looking for decile 5, and we are given k is equal to 5 because we are looking for decile 5. So k is equal to 5, and n is equal to 10, where we have 10 values in our data set. We now substitute the given to our formula. So we have position of decile 5 is equal to 5. This is our value for k. We replace n by 10. Okay. Then we copy the rest of the formula. Plus 1 over 10. Plus 1 over 10. We perform the operation. We have 10 plus 1 is equal to 11. Times 5, that gives us 55. And then over 10. Over 10. 55 divided by 10, that gives us 5.5. Now, decile 5 value is located in the 5.5th position. So, since our answer in step 2 is a decimal number, which is 5.5, we have to proceed to step 3, which is interpolation. Okay. So we first locate the 5.5th position, which is between the 5th score and the 6th score. Okay? Or 5.5th position is between the 5th and the 6th positions. So the score corresponding to the 5th position is 28. We have here 1, 2, 3, 4, 5, 28. And the score corresponding to the 6th position is also 28. Now, to find for the decile 5 value, we have to add the fifth score and the 0.5 score. So 5 plus 0.5, that gives us 5.5 or 5.5 score, which corresponds to 5.5 position. Okay, so decile 5 value is equal to 28, which is our fifth score. And we add 0.05 times the quantity 28 minus 28. This expression 0.5 times the quantity 28 minus 28 is our 0.5 score. Okay, adding the two, that gives us 5.5 score. So we get 0.5 again from the decimal part of our answer in step 2. Okay, this is our sixth score and the fifth score. They are just the same based on this data set only. So we perform the process or the operation, I mean. We have 28 plus 0.5 times 0, that gives us 0. So our decile 5 value is equal to 28. All right. So those are our answers for example number 1. Now we have another example. A group of students obtained the following scores in their geometry quiz: 8, 2, 5, 4, 8, 5, 7, 1, 3, 6, and 9. We will be looking for the decile 1, decile 5, and decile 7 values, and we will interpret the results. Okay? For our solution, let's take it one by one. Decile 1 first. To find the decile 1 value, of course, first step, we have to arrange our scores in ascending order. So we have 1, 2, 3, 4, 5, 5, 6, 7, 8, 8, and 9. For our second step, we have to locate the position of decile 1 value in our distribution. In here, we will be using the formula for deciles. So we have decile d sub k is equal to k times the quantity n plus 1 over 10. We are looking for decile 1, thus our k will be equal to 1, and n is equal to 11 because we have here 11 scores in our data set. We now substitute the given to our formula. So we have position of decile 1 is equal to k is equal to 1, that's why you have 1 here. N is equal to 11, that's why you have 11 here. And then copy the rest in the formula, plus 1 over 10. Perform the operation. So we have 11 plus 1 is 12, times 1, that gives us 12 over 10. 12 divided by 10, that gives us 1.2. So decile 1 value is located in the 1.2 position. Okay, so since our answer in step 2 is a decimal number, which is 1.2, we have to proceed to step 3, which is interpolation. So to perform the interpolation process, we have to first locate the 1.2 position based on our arranged values in step 1. Okay, so 1.2 position is in between the first and the second position. So it is here, somewhere here. Okay. The score corresponding to the first position is 1, and the score corresponding for the second position is 2. Okay. So to get the score, which corresponds to 1.2 position, we have to add the first score plus the 0.2 score. So decile 1 value is equal to 1 plus 0.2 times the quantity 2 minus 1. 1 here is our first score, and 0.2 times the quantity 2 minus 1 corresponds to our 0.2 or 0.2 score. So adding the two, 1 plus 0.2, that gives us 1.2 or 1.2 score, which corresponds to our 1.2 position. Okay? So let's perform the process. We have 1 plus 2 minus 1 is 1 times 0.2, that gives us 0.2. So decimal 1 value is equal to 1.2. Okay, so to locate 1.2, okay, so decimal 1 value is located in the 1.2 position, so somewhere here. Okay, so decimal 1 value is equal to 1.2. All right, let's move to decimal 5 value. So to find for the decimal 5 value, we have to first arrange the scores. So we have here, the scores are now arranged. Then we locate the position of decimal 5 value in our distribution. So we will use again the formula for decimals. We have here the formula. We are looking for decimal 5. So our k will be equal to 5. And n is equal to 11 because again, there are 11 scores in our data set. We now substitute our given to our formula. So we have now position of decimal 5 is equal to 5 times the quantity n is equal to 11 plus 1 divided by 2. So performing the operation, so we have 11 plus 1 is 12 times 5, that gives us 60 divided by 10, that would be equal to 6. So since our answer after using the formula is a whole number, which is 6, we don't need to proceed to step 3, which is interpolation. So decimal 5 value is located in the 6th position. So going back to our arranged values, so the score that corresponds to the 6th position is 1, 2, 3, 4, 5, 6. Okay, so we have here decimal 5 value is equal to 5. Okay, this time we will now look for the decimal 7 value. So again, step 1, we arrange the scores. We have here, the scores are now arranged. Step 2, we locate the position of decimal 7 value in our distribution. So we will again use the formula. We are looking for decimal 7, thus k is equal to 7, and n is 11 because there are 11 scores in our data set. We now substitute the given to our formula. So we have position of decimal 7 is equal to k is replaced by 7 and n is replaced by 11. So 7 times the quantity 11 plus 1 copy and then over 10, all over 10. We perform the operations. 11 plus 2 is 12 times 7. That gives us 84 and then divided by 10. Our result is 8.4. So since our answer after using the formula is a decimal number, which is 8.4, we proceed to step 3, which is interpolation. Okay? So we go back again to our arranged values in step 1. So 8.4th position is between the 8th position and the 9th position. So we have here 1, 2, 3, 4, 5, 6, 7, 8. This is the 8th position and this is the 9th position. Okay. So the score that corresponds to the 8th position is 7. And the score that corresponds to the 9th position is 8. So to get the score that corresponds to the 8.4th position, we have to add the 8th score and the 0.4 score. Okay, again, we have to add the 8th score and the 0.4 score. So decimal 7 value is equal to 7 plus 0.4 times the quantity 8 minus 7. 7 here corresponds to our 8th score, and the 0.4 times the quantity 8 minus 7 is the 0.4 score. So in here, 0.4 was taken from our answer in step 2, which is 8.4, the decimal part of our answer in step 2. Okay, 8 is our 9th score and 7 is our 8th score. Okay, so this expression gives us the 0.4 score. So adding it to the 8th score, we get 8.4 score, which corresponds to the 8.4th position. Okay, so we perform the operations. So we have 7 plus 8 minus 7 is 1 times 0.4, that gives us 0.4. So 7 plus 0.4, that gives us 7.4, which is now our decimal 7 value. Okay, so decimal 7 value is located somewhere here, and it is equal to 7 point. Okay, let's now interpret the results. Okay, let's begin with decimal 1 value. Decimal 1 value, which is equal to 1.2, means that 10% of the students obtained a score less than or equal to 1.2, and the remaining 90% got a score greater than or equal to 1.2. Next, for the decimal 5 value, which is equal to 5, a score of 5, which falls on decimal 5 value, means that 50% of the students obtain a score less than or equal to 5, and the remaining 50% obtain a score greater than or equal to 5. And then finally, for decimal 7, which is equal to 7.4, it means that a score of 7.4, which falls on decimal 7, means that 70% of the students obtain a score less than or equal to 7.4, and the remaining 30% obtain a score greater than or equal to 7.4. Okay, so that ends our solution for example number 2. And this ends our lesson on decimals. So to recap, decimals are the 9 score points which divide a distribution into 10 equal parts. These are the steps that we undergo in order to find for the decimal values. First, we have to arrange the values in ascending order or from least to greatest. Then we locate the position of scores in our distribution using the formula for decimals. V sub k is equal to k times the quantity n plus 1 over 10. If our result in step 2 is a whole number, no need to proceed to step 3. But if our answer in step 2 is a decimal number, we have to proceed to step 3, which is interpolation. Okay? So this ends our lesson or session for today, everyone. Hope you've learned something from our today's lesson. Thank you so much for watching and see you next time. Bye!